Welcome to Unit 8 of Chemistry 101 at Goodwin College Online. This unit deals with Chapter 8 in your textbook, and Chapter 8 deals with acids and bases. Some of you may be familiar with this, with the ideas behind acids and bases. For others of you, this may be completely new. Because we are dealing with acids and bases this week, there's actually one concept from the previous unit that we need to that you need to keep in mind for this unit, and that is molarity. Molarity is a way of measuring concentration of something dissolved, let's say, in a liquid. The formula for molarity is the number of moles of solute, so the number of moles of whatever you're dissolving, divided by the number of liters of the entire mixture. And it has to be liters on the bottom and moles on the top. And if you divide moles of solute divided by liters of solution, you get a number which describes the concentration or how concentrated your solute is in your liquid. And the units are pronounced molar. Sometimes it's said molar concentration. That's just another way of saying molarity. So that's the concept that you need to keep in mind for this particular unit. So before we get to acids and bases, I actually have to take a mathematical detour. And this is, I will admit, this is one of the more difficult portions of this course. So keep that in mind if this is a little bit difficult for you. So again, we're going to do a little bit of math before we get to acids and bases. So I want to talk to you about something called a logarithm. Again, some of you may have worked with logarithms before, that they're a mathematical idea. The abbreviation for logarithm is log, like this. So if I say log, that I'm basically saying logarithm. Logarithms are mathematical functions, and if you are unfamiliar with what a function is, it's not so important to sort of know the formal definitions. Just realize that a function is just a mathematical sort of mathematical fancy talk for turning one number into a different number. It's a set of rules that you follow that will turn one number into a new number. And a log, or a logarithm, is one type of mathematical function. So it is, you can think of this as a set of rules that you can follow. And if I give you a number, you can follow some set of rules and turn the number that I gave to you into a new number. So that's a brief introduction into what a logarithm is. But I haven't told you what the rules are yet. There are actually many different kinds of logarithms. They have slightly different variations on the spelling of this. One is ln, which stands for natural logarithm. You don't need to know any of this. We are only concerned with one type of logarithm, and that is usually either abbreviated log or log with a subscript of 10. These two things mean the same thing. And we'll get into what they mean on the next slide. So what is a logarithm? One way of thinking about a logarithm, and this is basically the way that I want you to think about it. A logarithm is a way of squashing a very large number or a very tiny number into a more reasonable looking one. So I said that logarithms are mathematical functions, and I said that functions are basically a set of rules that you can follow, and if I give you a number, you follow those rules, and those rules turn the number that I gave you into a different number. Well, the set of rules for logarithms, which we won't go into too much detail over, but we will go over in a little bit of detail. The set of rules for logarithm, basically, I could give you a huge number. If you followed those rules, you would take the huge number and you would end up spitting out a more reasonable looking one. You'd convert the large number into a more reasonable looking one. I could also give you a very tiny number. You could follow the rules, and you would also turn them into a more reasonable looking number. So I'll give you a few examples. Hopefully everyone will agree that 10 to the 22 is a huge number. It's 1 with 22 zeros. Another way of writing it is 1 times 10 to the 22. So this is just another way of writing this number up here. If you take the logarithm, which taking the logarithm means applying the set of rules that you don't know what the rules are, but just pretend that you could apply those rules to this huge number. If you take the logarithm of this huge number, the number that you spit out after you follow all of the rules turns out to be 22. So it's related to this exponent here. So all I want you to really have an appreciation for is that we took this huge number, we applied some mysterious rules, and that huge number got turned into a more understandable one. 22 hopefully is more understandable than 1 times 10 to the 22. So I'll ask you a question. 10 to the 23 is a huge number as well. It's 10 times bigger than this one up here. If I gave you this huge number, 1 times 10 to the 23, and you took the logarithm of it, what number would you spit out here? You can pause the video and think about this. The number that you spit out turns out to be 23. Again, it's basically just this exponent over here. And, excuse me, that turns out to be true for any number when the form of the number is 1 times 10 to the whatever. If you have 1 times 10 to the something, the logarithm of that is just going to be the something. So log of 1 times 10 to the 22, 22. Log of 1 times 10 to the 23, 23. This one, the next one is more difficult, and I don't expect you to know the answer to this, but I hope that you have an appreciation for where the answer is coming from, or where the answer should at least fall, what general neighborhood it should fall in. The number 5 times 10 to the 22, the number that's in these parentheses here, hopefully you will agree that it's bigger than this number. Because this number is 1 times 10 to the 22, this one is 5 times 10 to the 22. So this number down here is 5 times bigger than this one. This number is also smaller than 1 times 10 to the 23. For those of you who are pretty familiar with this and find this easy, this number down here, 5 times 10 to the 22, is actually 2 times smaller than 1 times 10 to the 23. But I don't expect you to sort of be that comfortable with this. All I really want you to realize is that this number here is somewhere in between this big number and this bigger number. Because this number is somewhere in between this big number and this other number, the logarithm of this 5 times 10 to the 22 hopefully is going to be somewhere in between 22 and 23. And it is. Unless you're a mathematical genius, you probably can't figure out what the exact number is. Sometimes students guess that it should be 22 and a half or 22.5. It actually is not. It's close to 22.7. But all I really want you to realize is that because this number is in between this one and this one, the logarithm of this number will spit out a number that's somewhere in between 22 and 23. And the reason I want you to have a sense of that is that I want you to realize that this is not just some logarithm, is not just some craziness. It follows a pattern. If you have 1 times 10 to the 22, the logarithm is 22. But if you have something that's a little bit harder, it doesn't have a 1 as a coefficient here, then even though you can't predict what number is going to be popped out here, you should at least have an appreciation that it follows a pattern. This number, the logarithm is 22. This number is a little bit bigger. The logarithm is somewhere in between 22 and 23. So, another way of thinking about a logarithm, and again, I know that some of you may be lost here, but there is a reason for talking about this. It'll become apparent near the end of the unit. Logarithm, another way of thinking about it is how many times do you need to multiply 10 against itself to get your original number? So basically, this 22 here means that I need to multiply 10 against itself 22 times to get back this number over here. 23 over here means that I need to multiply 10 against itself 23 times to get back this original number. And apparently 22.7 means that I need to multiply 10 against itself 22.7 times to get back the number 5 times 10 to the 22. Now, how do you multiply 10 against itself 22.7 times? Don't get caught up in that. Just realize, really the bottom line here is that logarithms will take huge numbers and apply a set of rules and turn them into more understandable ones. They also do the same thing for small numbers, and I'll show you that in a few slides. So, logarithms make really large numbers into understandable ones. If you want to do this on your calculator, and you will have to do some of these on your calculator, for those of you who have an iPhone, which I imagine is many of you, if you tilt your calculator app on its side, or if you tilt the phone on its side with the calculator app on, you will see this button. It's called the log button or the logarithm button, and basically this is the button that you need to press to apply the rules that will convert a really huge number or a really small number into a more understandable one. For the iPhone, what you have to do is you have to punch in your huge number or small number first, and then you press the log button. If you have a different calculator, the process might be a little bit different. So if you have difficulty doing this, you should email me and I can walk you through it for your particular calculator. It might help if you, I don't know, possibly email me a photo of your calculator if you're having difficulty. Also, if you can give me the brand name if I can't read it off the photo. Okay, so that's at least the beginning of the introduction to logarithm. So, as I mentioned earlier, logarithm is a way of squashing a set of rules that will squash very large numbers or very tiny ones into more reasonable looking ones. Here are a few other examples, but now we are dealing with tiny numbers. This number is 1 times 10 to the minus 23, and hopefully you'll appreciate that it's a very small number, much less than the number 1. The logarithm of 1 times 10 to the minus 23 turns out to be negative 23. So hopefully you see a pattern from what I was showing you 2 slides back. You'll also agree that 10 to the minus 22 is also a very tiny number. It's not quite as small as this one. This number is actually 10 times bigger. And the logarithm of 1 times 10 to the minus 22, you can pause the video and think about what the answer here is going to be. The answer is the logarithm of 1 times 10 to the minus 22 is minus 22. So we can play a similar game and we can pick a number that's somewhere in between this number and this number. And the number that I picked is 5 times 10 to the minus 23. 5 times 10 to the minus 23 is 5 times bigger than this number up here. It's also 2 times smaller than this number over here. The logarithm of 5 times 10 to the minus 23, again, I don't expect you to be able to look at this and figure out the answer, but it turns out to be about minus 22.3. So again, this number is sandwiched somewhere in between this one, and the logarithm of this number is sandwiched somewhere in between minus 22 and minus 23. So that's all I really want you to know. And hopefully you can appreciate that the fact that we are taking extremely small numbers, 1 times 10 to the minus 23, 1 times 10 to the minus 22, applying some set of rules, you don't need to know exactly what they are, and basically converting them into a number that's more understandable. In this case, it's a negative number, but hopefully you can appreciate the number minus 23 better than you can 1 times 10 to the minus 23. So whenever you have a negative exponent, like this, the logarithm, the answer to the logarithm of that number is going to be negative. And if you have a positive exponent, so like the ones that I was showing you 2 slides back, the logarithm will be a positive number. But again, the logarithm in this case will take really small numbers and turn them into understandable ones, although they will be negative. So this is a little bit of practice just to give yourself a sense of how well you understand what's going on here. The logarithm of 1 times 10 to the 4. What is the logarithm? So if I gave you this number, 1 times 10 to the 4, and I said apply the logarithm rules, what does the answer turn out to be? You can pause the video. The answer turns out to be 4, because in this case it's just 1 times 10 to the whatever. The whatever happens to be a 4, so the logarithm of 1 times 10 to the 4 is 4. Next one, 1 times 10 to the minus 4. What is the logarithm of 1 times 10 to the minus 4? So I give you this very tiny number, I ask you to apply the logarithm rules, and some other number is going to be spit out. What is that other number? You can pause the video. The answer here is minus 4. Again, pretty straightforward when the number that you're given is 1 times 10 to the something. This same thing, 1 times 10 to the something. I think there are a little bit, maybe slightly more difficult ones. Logarithm of 100. Again, you can do this on your calculator, but you can pause the video and think about this as well. I can explain what the answer is without doing your calculator. So the answer here is the number 2. The reason it's the number 2 is because the number 100, the number that I'm giving you, that you're using to convert into the number 2, the number 100 can be written as 10 to the 2. It's 100 is also 10 times 10. Because it's 10 to the 2, then if you just substituted in basically the phrase 10 to the second power over here, then you would see that the logarithm of 100 is just going to be 2. Next one, logarithm of 0.01. Again, you can pause the video and think about this. You can punch it in on your calculator if you'd like. And so the answer over here is minus 2. The reason is that this number over here, 0.01, can be written as 1 times 10 to the minus 2 power. Because it can be written as 1 times 10 to the minus 2, then the logarithm of that is going to be minus 2. So, as far as what I want you to be able to do with logarithms, I want you to be able to use the logarithm button on your calculator. I want you to have a general understanding of what it does to big and small numbers. What I mean by that is it will convert them into more understandable numbers. If your starting number is bigger than 1, then the logarithm will spit out a number that's bigger than 0. If your starting number is less than 1, your logarithm will spit out a number that's less than 0. And so that's the end of the introduction to logarithms. We're going to talk about acids and bases next. I apologize if your head hurts at the end of this, but I do promise you that it comes up at the end of this unit. So that's the end of logarithms.